Okay, so let's start our next lecture. In our previous lesson, we have studied about attribute maps, advertised map, suppressed map. Now, the next one is the unsuppressed map. Now, let's see how we can use unsuppressed map and in what condition. So, in our previous section, we have seen that we advertised some subnets from R11, right? So, if I go to R11, show IP BGP. So we can see that we have advertised some subnets, right? From 172.168 1.0 2.0 3.0 and 4.0 from R11. So at R6 and R7 we are doing the summary of those routes, and we are sending summary only routes. And as we have studied in our previous lecture, that if we are using this keyword summary only, right? If I do a show run section router PGP, so when we use this keyword summary only, right? So in that case, so if we don't use this, let's say we are not using this keyword as we discussed in our previous lecture. So by default, router 6 is going to advertise the summary. Let's say we are doing the summary 0.0/21, and along with that summary, it will also advertise all the individual subnets, right? Like 1.0, 2.0, 3.0, and 4.0. So now we are sending as a summary only from R6 and from uh, R7 both. From R7 also we are just sending the summaries. Show run section router PGP. Sorry. So if I go to R8, let's say show IP BGP. Now you can see that R8 is receiving the summary from R7 and R6. So based upon the criteria that we already studied about the path attributes and all, so it is selecting the best path for the summary via R6. So let's say if I do a trace route 172.168 dot, let's say 1 by 1. So because the best path is via R6, so it is going via 6, 5, and then 11. Same we can, let's try with 4 2.1. It is going via R6, right? 3.1 also it is going via R6, and 4.11 it is also going via R6. So now we can come across a situation that for a particular subnet, let's say, so we are advertising these four subnets, right? 1.0, 2.0, 3.0, and 4.0. Let's see what we want is that for all the routes in that summary 1.0, 2.0, 3.0, R8 should go via R6. Okay, let's say, let's write it here. So for 1.0, 2.0, 3.0. So for these three subnets of our summary /21, R8 should go via R6, but for the subnet 4.0, it choose the path via R7. Okay, so what we can do is we can use unsuppressed map here. Okay, so let's go to R7, R7, and what we can do is let's create one prefix list. Let's say IP prefix list CCIE unsuppress. Okay, sorry. Okay, so permit. So we will permit the subnet that we want to make best via R7. Let's say 4.0/24. Okay, I'll create one route map, let's say with the same name, or let's say just say unsuppress. I will call this prefix list here right? The name of the prefix list is this one. Now I just need to do one thing. I will go to my BGP process. So for all our maps that we have studied so far, be it advertise map or attribute map, so or suppress map. So all those maps we were using with that long command, right? That the aggregate command, aggregate address, summary only, and that after that we were using all the maps. But this unsuppressed map we cannot use there. So it is there to use with particular neighbor only. So for example, my neighbor is R8, right? So I'm sending my summary to R8, but along with that summary, I want to set one condition that do not suppress one particular subnet, right? So unsuppress map, and now I will call this unsuppress map or the root map that I have created here. Okay. Now let's say clear IP BGP star out. Let's go back to R8, show IP BGP. Now you can see R8 is receiving the summary from R6 and R7. The summary is based by R6, right? And now from that summary, we are receiving this 4.0 subnet individually, right? So, and as we know that the very first thing that a router check is the longest prefix match, right? So if we are doing a trace route, let's say now 172.16.1, sorry, 172.168.1.1, source loopback is 8. So now R8 is going to check its routing table, and for this it is receiving the summary, right? And the summary is best via R6. So let's say do a trace. So it is going via R6, right? Same, let's check for 2.1, it's going via R6, right? Check for 3.1, going via R6. Let's check now for. Now you can see the path for this particular subnet is changed. Why? Because when it is checking in the routing table for 176.72.68.4.1, right? So it is receiving it in the individually, right, as a 4.0 slash 24. So based upon the highest prefix length, so it is choosing R7 as a best path. Okay, you can see it is receiving it via R7 with highest prefix length, that is slash 24, and rest of the subnet it is receiving via or via the summary only. Okay, so this is how we can use the unsuppressed map in this type of condition. Okay, so let's check a few more things. Uh, show IP BGP. Okay, so now let's say I'm at R4. I'm receiving few subnets. Let's say these three: 192.168, 1.0, 2.0, and 3.0. So if you remember the path selection criteria, right? Let's go back to our slide. Let's go back. Path selection criteria. Let me go back a bit. Here it is. So here we have the path attributes, and in the path attributes, let's check. Here it is. So this is these are the path attributes, right? So when a router gets the same information from two neighbor, then it is going to check one by one these path attributes, right? So the very first thing it is going to check is the weight, then local preference, then locally injected route, AS path. Then it is going to check the origin code for those two routes, then MAD, then neighbor type, then IBGP metric to reach next hop, right? So it is going to match one by one. So now let's say this is router R1, right? So it is receiving a particular subnet from two neighbors. Let's say this is R2 This is R3. So R2 is sending R1 some route, let's say 1.1.1.1, and R3 is also sending the same route 1.1.1.1. So R1 is going to match all these criteria. Okay, first it is going to check weight, then local preference, then local injected route, then AS path list and all. So till this attribute IGP metric to reach next hop. If everything is same, then here we can decide in BGP if you want to load balance the traffic or not. Okay, because after that you can see we have older EBGP route, right? So to test this, let go back to R4. So now R4 is receiving uh, 1.0, 2.0, and 3.0. So it is selecting R6 as a best, right? Here also R6. It is selecting it best on the basis of older EBGP route. How we can say that is, let's say if I clear, if I say clear IP BGP, right? Neighbor, sorry, clear IP BGP, and this is my best. So if I refresh the route for R6, right? In, let's say what happened now. Show IP BGP. Or let's say clear IP BGP. I'm clearing R6. If when I clear R6, then the routes it is receiving from R7 will be the older routes, right? And older EBGP route will win, right? Let's say I clear the neighborship star soft show IP BGP. Now you can see R7 is the best path because now we break the neighborship of R6, then the route that it was receiving from our R7 becomes the older one. So based upon that, it is uh, selecting R7 as the best one, right? So as we discussed, so if all the path attributes till here are same, then we can think of the load balancing in VGB. Okay, how we can achieve that is, let's go back to R4. We just need to give one command. Under my BGP process, I will say by default the maximum path in the BGP selection is 1. That is why it is selecting only one path, right, as best. So now I will say, let's say maximum path is 2. Let's say clear IP BGP star in. Okay, show IP BGP. Sorry. Now you can see here, you can see a small m, right? Small m means multipath, right? So now you can see it installed both the path as best, right? Even if you check show IP route, you can see here it installed both the routes in the routing table. Even if you check show IP self, let's say for this network, you can see the next hop is both 6 and 7. So this is how you can do load balancing in BGP. Okay, let's test one more thing. I'm at R5. Show IP BGP. Show run section router BGP. So here we have also maximum path 2. So you can see it is also load balancing, right? Okay, let's test something here now. I'm at R5. let's set its neighborship between R5 and R6. Show running section router BGP. So I'm setting the neighborship between R5 and R6 to show you something. This is how we can set the neighborship. And if we want to unset it, we just need to run the same command, and in front of that we can use no. While doing this, we need to be very careful, because sometimes what happens is, instead of copy pasting, we can do like this: no neighbor and this, and we forgot to mention shutdown and we enter. If we do like that, then all the configuration related to that particular neighbor will be erased. So we need to be very careful. So what I do normally in the live network, first of all, I just copy the command, and then I do a control A, just type no, and then I enter. So just make sure you are not erasing the configuration. Okay, so the our neighbor is down now. Show IP BGP summary. Now let's go back to R5. Show IP BGP summary. Okay. Now also let's bring the neighborship between, I think, R11 and R8. We don't have the neighborship. Yes, so let's bring it up. Interface E6/0, no shut. Let's wait. Show IP BGP summary. Okay, I'm at R5. Show IP BGP. Okay, let's try for this subnet. Uh, okay, so these are the three subnets, right, that we are receiving from 7 and 11, and the criteria is same, right? So it is selecting based upon the older route, eBGP route. So here also, if you see here in the section router BGP, we have this maximum path to command, right? But still there is no multipath, right? If I do a show IP self /24, you can say it only one next hop is installed, right? That is 7. So right now the 7 is the best one based upon the older eBGP route. Why it is happening is, let's go back to R4. So in case of R4, what was happening is, if you see here, so for example, this is the route received from R6, and this is the route received from R7. You can see the both the routes received were from the same AS number, right? You can see they are coming from the same autonomous system number. You can see the list is same, right? So they were coming from same autonomous system AS 200, right? But if you check on R5, show IP, show IP BGP, here you can see that these routes are not coming from the same AS, right? Let's say you can check here, it's 400, 300, 200, 300. So this route, it is coming from AS 400, and this route or this subnet, it is coming from AS 200. That is why the AS path, maximum AS path to command is not working here. So there is a hidden command that we need to use here in this case. Okay, so what we can do is, the command is not visible normally. So if you do a router BGP show let at address family, so the command is BGP best path. Okay, now I say if you do a tab here, it is not going to work. Okay, multipath relax. Okay, I think I also need to give AS path multipath relax. So this is the command. You need to remember this: BGP best path AS path multipath relax. Now let's do a clear IP BGP star soft show IP BGP. Now you can see M here, right? So now even if we are receiving the information from different AS, now it is doing the load balancing. Correct. So this is how we can use this. So this command is hidden. We need to memorize it. So the command is BGP. Let me show you again. So it's BGP best path AS path multipath relax. So this is the command. Okay. And if you check a show IPsec now 192.168.1.0/24, now you can see it is installing two paths, right? Okay, so one more topic that I wanted to discuss was, so normally what happened is in the enterprise network or in the large networks, what happened is, let's say this is customer A, right? And this is a large enterprise network, let's say this one. Okay, so now this is ISP1, right? This is ISP1, and ISP1 is giving us the MPLS service, let's suppose. So this is one of our site, right? And this is R1, this is the ISP router. Let's change it a bit. So this is ISP1 CE router, right? ISP1 CE router. So ISP1 is giving us the MPLS services to connect to our different sites, and maybe we have some our big data center somewhere, so it is giving us the service. So this is the ISP1 CE router. This is ISP1 CE2 router. So ISP1 given two links to us. Okay, so they installed their router here. So this is, let's say, ISP1, it's their PE router. This is also their PE router, right? Let's say this is their MPLS network or their cloud. So normally what happens is, let's say if we are a big enterprise customer, so there will be around 10,000 or maybe 20, 30, 40,000 routes in our MPLS network, right? In our data center and including all our remote site routes. So we are having around 20, 30,000 routes in our network. So we will be receiving all those routes via MPLS in our network, right? So let's say this is the ISP router, and we are receiving all the 20,000 or 30,000 routes from our data center. So this is our data center, we are receiving it. Same case here on CE2 also, let's say we are receiving those 20,000 routes, and we have some sort of IBGP here, and we are receiving the IBGP routes also, and our communication is happening, right? So on the PE side, let's say this is our LAN network, and we have only let's say 10 subnets on this particular site, right? So to the PE we will send only the LAN subnets, right? Based upon these subnets, the MPLS network of the ISP, it will send or advertise these routes to our data center, or maybe all of our sites, right? Including, let's say this is the site number 2. So they will advertise all our 10 subnets or our LAN subnets to all of our locations. So they are using these two routers. Same case, 10 routes, it will be they will be advertised from CE2 also, 10 subnets, right? So now let's say, and our total routes, as we discussed, let's say from our geographical locations and from all our data center, they are 20,000. Here also we are receiving 20,000 from our data center, right? 20,000 routes. Let's say there was some migration on this, or maybe some IS upgrade or something on this C router, right? And they did some bad configuration maybe, because while they were sending advertising the LAN routes of the site A or site 1 to the PE neighbor, so they are using the filter list, or they are just filtering the routes, and they are allowing only the LAN subnets, and we have only 10 LAN subnets for this customer, right? But somehow they made some mistake on the filtering, and what happened is all the 20,000 routes that CE2 was sending to CE1 router, so they all advertised to the PE router, right? This is not the only customer that is being terminated on the Ps, because there will be a lot of customer the ISP is handling. So if a lot of customer did this kind of mistake, or I mean during the migration or something, if this type of things happen, then the P routers can be crashed, right? They cannot handle so many routes, right? So normally in the live networks, what the ISP does, they set some limit of prefixes received from a particular neighbor. What exactly happened is, this is the PA for example. So this CE R4 is having neighborship with this one, right? CE1 is having neighborship with PE1. So R6 will set the limit here that I will receive maximum 10 prefixes only from this particular neighbor, right? Because we have only 10 subnets in the LAN of this site. So they will receive only 10 prefixes. If they are receiving more than 10 prefixes, then they will break the neighborship, right? So the router will sense that there is some issue, maybe some filtering issue or something. That's why they'll break the neighborship. Okay, so this is how we can use the maximum prefix setting on some router. So let's to demonstrate this. We can try here is, okay, let's go to R6, show IP BGP summary. So R6 is having neighborship with R4, which is the CE1 router, right? So what we can do is, let's say show IP. Let's check how many prefixes we are receiving from R4 right now. So from R4 we are receiving 1, 2, and 3. 3 prefixes we are receiving from R4, right? So let's say I go to my BGP process, router BGP 200. I'll type my neighbor command, and I will type maximum prefixes. Okay, so this is the criteria starting from 1 to this is the limit. So let's say right now we are receiving 3 subnets from R4, right? Okay, so now let's say the maximum prefix that we can receive from R4 is 2. If we receive more than 2, then neighborship will be break. Now you can see already the neighborship is breaked. What it is saying, number of prefixes received from R4 exceeds the limit, right? So now if you check show IP BGP summary, it is saying that the maximum number of prefixes the limit is crossed, right? We have set how many prefixes maximum? 2, right? And we are receiving how much? We are receiving 3 prefixes, right? So if you see this kind of message in the bracket pfxct, it means that your ISP has set, or your neighboring device has set some limit, and we are sending, or we are crossing the limit, right, of the maximum number of prefix. If I go to R4, show IP BGP. So what was the route that we were sending to R6? For example, uh, 4.4.4, sorry, 55 is subnet 4, or let's 4.4.4.0. Let's, I think it's the loopback. Let's try to shut it. Show IP interface brief, loopback 0, interface loopback 0, shut, right? Now let's check at R6. Show IP BGP summary. So your neighborship is not going to come up. Okay, let's show IP BGP summary. Let's try to clear the neighborship from here. We have cleared the neighborship from R4. IP BGP summary, but it is not going to work sometimes. So you need to do what? Show IP BGP summary. You need to clear it from here. Show IP BGP, sorry, clear IP BGP, and then clear the neighborship. Show IP BGP summary. Okay, let's wait. Now it's okay. Now you can see the number of prefixes received from R4 reaches 2. Maximum is 2. So now you can see the neighborship is up, right? So you will find sometime in the live network that sometime if there is some problem on the filtering and all, and sometime you will find that the neighborship is down due to the maximum prefix limit is crossed. Okay. Okay, one more thing I can show you here. Okay, I'm at, let's say I'm at R4, and if I do a show run section router BGP, so R4 is the ISP C router, right? And all these 1.1, 1.1 is the customer, right? Customer router. Let's say set a description also here. Customer router, right? So this is the customer router. So now if you see here on the customer router, this ISP CE1, they set some route map, right, in the out direction. So what happened in the live scenario is, in the enterprise network, so as we discussed earlier, so let's say we have taken the ISP MPLS link from the ISP. So the ISP, they put one device on our site, right? And our LAN is terminated on that particular router. But generally they do not give us permission to go into the configuration mode and all, right, to their devices. They will give us permission to run some show commands, maybe show IP BGP summary, show IP interface brief, show interface description. And I'm pretty sure I have never seen that you can run this, even the show run section BGP, because running command is not show run is not available on the ISP devices for you, right? You are the customer, you cannot show what they have configured. You can just check some basic things on their device, right? So you can come across a situation where, let's say you are doing something, maybe you are doing some troubleshooting, and I don't know what, well, there can be any requirement, right? Because it happens to me a lot of time. Sometime I am doing something on my devices, and somehow the ISP devices which is on our site, it is not maybe allowing our routes, right? Let's say I advertise some route from our LAN, and I checked in our data center and I'm not receiving the routes just because they have some policies on our site CE device. So let's say this is the CE device, the ISP MPLS router, which is, let's say, on our site, right? So it has some policy in the out direction. They applied some route map for the outgoing updates, right? And for the incoming updates also. So let's say from I'm sitting at here on R10, right? And I'm advertising something. Let's say, let's try this actually, and it will be more clear. Okay, let's go to R4. First, let's allow the route from or another site where my neighbor is 46.1.1.6, right? I will say allow is this command we already discussed in our previous lecture, right? So by default, if I'm receiving anything from my, if I receive any update and if I find my own AS, then I'm not going to allow that update, right? For the loop avoidance. But we can come like in our current scenario. So this I'm at R9. So this is our site 2, right? So if I'm advertising anything from here, so when this information will receive at R4, it will find AS number 100 in the AS path list, right? So it is not going to accept this. So, but we know that there is no looping situation, there are no redundant connections, so we can use this command to allow these particular routes, right? So we already discussed this in our previous lectures. So now let's go back to, let's say, R9, which is our another site, right? Let's say show BGP summary. Let's advertise something from here. I create one loop back, 99.99.99.99. Mask is 255, 255, 255, 255. Router BGP 100, right? And let's advertise it. Let's first go to R4, run section router BGP. So to R1, we are using this route map in our direction, right? Show route map. We are calling one prefix list here, right? In our direction. Let's say what is there in this prefix list. Everything is allowed. So let's create one sequence number, IP prefix list. This one, sequence number, let's say 4, deny 99.99.99.99/32. Show IP prefix list. Okay, cool. Now let's try to advertise this. 255, 255, 255, 255. Okay, we have advertised this. I'm going to R5, and just for the demonstration, let's shut this link, serial 3x2 interface, serial 3x2 shutdown, show IP BGP summary. Okay, so now I'm at R4, show IP BGP. I'm receiving this, right? And now you can see I'm also accepting a route which is originated in the same AS as R4, right? Because we have given the command allow AS in. If I go to R1, show IP BGP summary, show IP BGP. Now we advertise some route from our one site, but we are not receiving that route in our site 1, right? So I logged into the ISP or the CE router that is provided to us, R4, but somehow, because this is the ISP router, I'm not able to run show run section BGP or something to check the policy what exactly is happening, because I can check here on the ISP router when I log in to my ISP CE1 router. So right, this is the CE1 router of our site where we want to receive those routes. So when I logged into that device, I can see that I'm receiving that route. But somehow, this particular router, it is not advertising this route to our LAN, right? Here we are receiving this 99 subnet, 99, 99, 99.99. We are receiving it from our site 2, right? But somehow this router is not advertising this particular subnet into our LAN. So to check this, what I can do is, because I have limited access of commands, I can just check few things on this router. This being a ISP router, they have given us the permission to run few basic commands. So in that condition, one command is very useful to check the policies, and this I also use a lot of time. What we can do is, I'll run show IP BGP summary. So this command will be always allowed by the ISP. And another command that you can run is, this is our LAN router, right? R4 is the ISP router. So what to check the policy is, what you can do is, you can run this command show IP BGP neighbor IP. Then you can say policy detail. Now, because see, this is the ISP router, right? And there can be a lot if you just say show IP prefix list, because this is we have run only one prefix list. That's why you are able to see it. Okay, this is the prefix, but on the real time you will see a lot of prefix list and ACL, right? And just if you say a show route map, you will be having a lot of route maps, so you will not be able to segregate on our LAN device what is the route map or the access list which is applied. So you can just run this command. This will particularly show you what are the policies that are applied to a particular neighbor. So what I have done is, I have checked show IP BGP neighbor. This is our LAN device, and I say policy detail. Now it is showing that R4, its neighbor is 1.1.1, and it is configured with the two policies here. Next of self, it's okay, and it is also applying one route map in the out direction. Now you get to know that okay, this ISPC1 router is applying this route map in out direction to our LAN device. So you can open this route map, and now you can see okay, in this route map they have also called one prefix list. Let's try to open it. Show IP prefix list. Now here you will find out that they are denying this particular subnet, right? So now just by that command show IP BGP neighbor IP policy detail, you get to know that there is some policy on your C router here that is not allowing your subnet that you advertise from your remote site to your LAN. Now you can log a ticket with your ISP, and you can ask them that they need to allow this particular subnet into your LAN. Then they are going to remove this, or maybe set a permit statement, and only then you will be able to see those routes in your LAN. So this is how you can use this policy detail command in the real enterprise, or maybe whatever network you are working with, just in case you don't have much access on the ISP router or to any router, right? So you can check the policy like that. Okay, so I just want to discuss one more topic here, and then we'll close the call for today. Let's say, so as we know, we have some in the BGP also we have private and public range, right? I exactly don't remember, but the public range starts from 1 to 6400 and 512 something, and after that we have the private subnet. Let's say R7 is having one private AS number, let's say 65500. Okay, so now, like the private IP addresses, we also have the private AS number, which are also not allowed over the internet, or let's say it's the ISP2 in AS300. So before it is advertising that route that are coming from R7, it is going, it needs to strip off this particular AS number, right? Because these private BGPS number, they are not allowed over internet or while they are advertising it to some other ISP. So this information should be removed. So how we can achieve that is, let's go back to R7 for the to demonstrate this. R7 show IP BGP summary. Remove the normal. Let's remove the router BGP from R7. Create new one. Router BGP. Let's say 65500. Its neighborship with, let's say, R5. Remote AS is 100. Its neighborship with 78. Remote AS for 300. Right. Let's go back to R5. Let's directly go to router BGP 100, neighbor 57.1.1.7, remote AS 65500, right? BGP summary, you can see BGP is come up. Let's do this at R8 also. Router BGP 300, sorry, neighbor 78.1.1.7, remote AS 65500. Show IP BGP summary. It will come up. Okay. So now at R7 we are having the private AS number. So if you are advertising something from R7, let's say show this brief router BGP 65500 network mask 255.255.255.0 show IP BGP IP BGP star soft. Let's check at R8. Show IP BGP. So R8 is receiving it, and let's go back to, or maybe we can directly check at R9. Show IP BGP. So you can see when R8 is sending this update, right? So R7 advertise one subnet to R8 and R8 send it to R9. So at R9 we are receiving the private AS number, right? And we know that we cannot advertise the private AS numbers to another ISP or maybe to internet, so they are not routable, right? So what we can do is at R8, so before advertising this subnets to R9, what I can say at R8 is at R8, I can give one command router BGP 300 neighbor. My neighbor IP is 108.119. I will say remove private AS. So it is going to strip off the private AS before advertising the updates to R9. Star soft. Now let's check at R9. You can see the R7 update is coming with, it is not having this private AS number, right? So this is how we can remove the private AS. But now you can also have a look at R9. like for example this route, let's say these routes, right? So here you can say, let's say 172, this, let's talk about this route. So this route is originated in at R11, so originated in AS400, then it went to R5, right? It originated at R11, it went to R5, then it went to R7, then it went to R8, right? If I go to the topology, this subnet originated from here, right? Then it went to here, it sent to R7, R7 to R8, and then it sent to R9. So in this case, you can still see the private AS, right? It is still visible in the updates here. But for this update 7.7.7, you see after we given the command remove private AS, this is no more visible here. So the effect of this command will be on the directly connected neighbor only, right? So this is my neighbor which is in 6550, right? So the effect of this command will be for all the subnets which are originated from R7 only. So if R7 is working as a transit router for any other routes, so this command is not going to work. So this we need to make sure. Okay.